All right, guys, this week's lesson, we're in week 3, semester 2, and we're looking at lessons 86, 87, and 88. So again, you just gotta watch this video for the entire week instead of one each day. Hopefully it's making things a little bit easier. So lesson 86, we're looking at area of a circle. So again, if we want to kind of look at this in terms of we were to draw out a grid and then count up the full squares and partial squares and half squares and all of that, we could get to an estimate. But better than an estimate, we're going to use an actual formula. So if we did the square, obviously the area of the square would be too much for the circle. If we did a square inside here, it'd be too little. So it's going to be somewhere in between that. So estimate, go through, count up how many you have. Okay, the radius we know is 1, 2, 3. If we went through and counted up all of them like they do here, all the full ones are nearly full, then half right here. Count it up, you get, depending on which ones you counted as full or halves, you get around 28. 29, 30, 27, 26, it just depends. Okay. And we have in our reference sheet, I know we've already talked about it, but even better than drawing out a grid and counting up, we can use the formula, which is pi r squared. So area of a circle, pi r squared. Now, pi is just a number, so we use this symbol form. Why do we use that symbol? Well, because pi is an irrational number that continues on infinitely. It has infinite number of decimal places. So we have to round it off eventually, whether it's the second decimal place or the 2 billionth decimal place, we have to round it off somewhere. So most commonly for pi, we'll use this little symbol right there. We usually use 3.14. It's not equal to 3.14, so sometimes you'll see it. These little squiggly lines indicating about or an approximation. So we can sometimes use 3.14. Sometimes we'll be told to use 22/7 fraction, so it's still not pi, it's just a fraction rounded version of it. Or sometimes we can just leave it in terms of pi. And see that. So the example we had said that the radius was 3 centimeters. So area of the circle pi r squared. So you know the radius, we just plug it in for r, square it, times it times pi, 3.14, 22/7, or leave it in terms of pi. Either way, that's what we're doing. So if I have my circle, okay. Now radius is 3. Again, radius we can draw anywhere because it's from the center to the side, and we really have infinite radii, not radiuses, radii, plural, in there. So I'm going to plug in this number here. The area equals 3.14 times 3 squared, which is 9. We get 28.26. It's still area, so it's units, centimeters, inches, whatever it is, squared. So if we're rounding it, and we want to round to the nearest, we would have done 28. We got 28.26 and using that. In your problems and the homework, or the review, or the test, it'll say to use 3.14, 22/7, or leave it in terms of pi. Just use whichever one it tells you to, so that way we're not getting different answers just based on rounding or anything like that. And usually it gives that to you because the decimal is easier. If we're using 22/7, we're going to have something that'll cancel out with the 7, more than likely. So just use whatever form of pi it tells you to. And it's all a rounded form because it's a decimal that continues on forever. Okay, so pi r squared, there's your formula. All you need to know is your radius. Plug it in for r and compute, and you're done. Don't forget your units, centimeters, feet, inches, whatever it is, to the power of 2. So square centimeters, square feet, and square inches. We practice that together when we get to class. All right, lesson 87, finding unknown factors. So if we have an unknown, we have an x, a y, an n, or whatever it is, an unknown, well, we want to know what it is. And we've seen examples like this, where 2x equals 10. Oh, I know 2 times 5 equals 10. Yes, that's correct, but just the trial and error method, that's not going to be the most efficient way to do these down the road. So how we go about solving this is I have 5n, or 5 times this unknown, equals 21. I want to know what number I can plug in for n to make the left and the right equal. Well, how do I go about doing that? Well, first, I know this is multiplication, so I need to divide. So we think inverse operation. So if we're adding something and we want to cancel out, we need to subtract. If I'm subtracting, I need to add. If I'm multiplying, I need to divide. If I'm dividing, I need to multiply. And this equal sign, again, is like a scale. If I do something to one side, I can't just do it to one side and not the other, where it will become unequal. So I got to keep them equal. So if I divide 5 by 5, I do that because I want to be 1n. I want to get rid of this 5. When we get rid of it, so to speak, we're not just making it 0 or just ignoring it. We're dividing and canceling it out. I have to do the same thing over here. And when I do that, I end up with 21 divided by 5, which gives me 4.2. And then I always talk about this. You don't have to do it for every single homework problem for the rest of your life. But if it's a test and you're really unsure, does that seem right? We'll plug it back in. We plug in 5 times n, or 5 times 4.2. It does equal 21. So we know we did it correctly. There's just a few extra seconds to plug it back into your original expression to make sure it works out to be true. And if it's not true, okay, I know that's not the correct answer. I need to go back and check my work. But this case, it did work out to be true. Okay, so this one, I'm going to have 0.6 times m equals 0.048. So we're multiplying, so we need to divide. And we divide both sides by 0.6. We're going to get 0.04. So again, I can do 0.0. You don't have to punch in the 0. I usually don't, just I guess to save time. So 0.4048 or 0.048 divided by 0.6 or 0.6, and we get 0.08. So that is what m is equal to. Do division. If you're doing the division by hand, just make sure, like they show you right here, move your decimal 1 to the right, 1 to the right, so that way we're dividing by a whole number. It doesn't matter if the x is on the right or the z or y or whatever it is, our unknown is on the right or the left. We still want to solve for it. So if I have 45 equals 4x, and this is an equal sign, you know, if x is over here, I just want to get it by itself. This is multiplication. So I dividing by my coefficient. Any number divided by itself is just 1. So even though we write it as x, this is really just 1 times x. We usually don't write in that coefficient because it's not necessary, it's implied. But if it helps you to see it's 1x or 1 times x, that's fine. So 45 divided by 4 is 11.25. And then if this was a test, you could just circle it like that. If you prefer to have it the left to right way, you can rewrite it like that. It's the same thing. Okay, that practice set we will go over together in the last lesson for this week. Okay, is lesson 88. We're using proportions to solve ratio word problems. So we've done our ratio boxes for a long time. We have a ratio that we're given, okay, 5 to 7. So there's our ratio. Our actual count, we were told there was 20 salamanders. We're comparing salamanders to frogs. 5 to 7, 20 to F. Unknown. That's what we want to figure out. So we set those up in equivalent fractions. 5 over 7 equals 20 over F. 5 and 20 both be in the numerator, and then 7 and F on the same position, so 7 and F are both in the denominator. We cross multiply. If 5F equals 7 times 20, then I divide by 5. F equals 28. So if I have example 2, 3 sacks of concrete will make 12 square feet of sidewalk. Predict how many sacks of concrete are needed to make 40 square feet of sidewalk. Okay, it's going to be the same ratio that we're using. So we set up sacks, square feet, so ratio. You can do actual and ratio, it doesn't matter. We just usually put ratio first because that's what we're given first. So the ratio was 3 sacks would make 12 square feet, so 3 to 12. 40 square feet, I don't know how many sacks of concrete. So 3 to 12 equals X over 40, and they're equal, so we can use our cross multiplication and division. So cross multiply and divide. X equals 10. So it's going to take 10 sacks or bags, or sacks is what they're called, to make 40 square feet of concrete. It's important to be able to know that so that we're not buying way too much or not nearly enough. We only have 2 practice set problems, so we'll get those when we return to class. Love you guys.